Hello, this video represents the second in a series of videos on the Muskox copper nickel PGM project that SPC Nickel has in Nunavut. And in this video, we'll be looking more at the geology of the Muskox intrusion, our property position, and as well as some of the mineralization that we see at surface and why we think this mineralization and the opportunity on this project is so unique. As I mentioned in the last video, we will be doing mentioning some forward-looking statements, so make sure you do your own research. So to continue on, after we made the decision that the Muskox intrusion was our target because of the relationship that we see between other giant deposits like Norilsk, we began staking ground in 2021. Nunavut had just switched from ground staking to map staking, which was a big advantage for us. So we were able to go in and stake around 30,000 hectares. So that would be the area in the black on the maps on the right. And we also consolidated the camp through an option agreement with a company called Bathurst Metals in 2023. So that would have been for the properties in the red. So currently we have about 48,000 hectares, or about 470 or so square kilometers of ground that we have control through staking. And that represents all of the Muskox intrusion that is currently available for staking. SPC Nickel controls it all. And if you just look on the maps on the right, you can see the distribution. And I should point out that the map on the right goes beneath the map on the left. So our claims extend over a distance of about 125 kilometers. So it's a massive property position with huge exploration upside. So looking a bit more at the geology on a very schematic sort of view, the Muskox intrusion kind of has an interesting history. It was first discovered in the 50s by Inco as they were doing reconnaissance flying in the Arctic. So they were flying around in a fixed wing plane looking for gossans. And one of the characteristics of the Muskox intrusion are these massive gossans that are developed along the margins. So when the geologists saw this, they noted it, and that's when Inco came back and spent 2 to 3 years exploring the Muskox intrusion. Since then, there's been lots of academic work on it, and it's really one of the largest and least deformed ultramafic intrusions in the world. As I mentioned before, if you take the main intrusion, which we see here, plus the feeder dike to the south, it's about 125 kilometers long, and that's what's exposed. The intrusion ranges from about 200 to 600 meters in the feeder dike to the south, and up in its maximum, it gets up to about 11 kilometers wide in the main portion of the intrusion that you see here. The feeder dike extends for another 60 kilometers to the south from this image, but it also extends underneath the main intrusion. And you kind of have to look at this intrusion as kind of a funnel-shaped body that dips about 3 to 5 degrees to the south. So that's really kind of an interesting fact about this intrusion because of its shape, which is kind of a bowl shape, and its dip being to the north. You're not just viewing one stratigraphic horizon within its intrusion. Over that 125 kilometers, you're actually seeing over 8.5 kilometers of depth extents from the south to the north. And that's interesting when you look at it from a big picture and where mineralization is that the fact that you can find mineralization in the most southern part to the most northern part speaks to the potential of this project, because that also means that there's mineralization over 8.5 kilometers of depth extent as well. As far as geology goes, the Muskox is intruded into older country rock that belong to the Wapme orogeny, and that would be predominantly sediments and some more felsic intrusions. So those are kind of the pinks and the purple units. And it was intruded right at an unconformity between the older rocks of the Hepburn and the Recluse Formation and the younger rocks of the Hornby and the Dismal Lake Formation. So it came in at this unconformity, due to the Mackenzie Large Igneous Event, which brought mantle material up through the feeder dike into this large intrusion, and from the intrusion that same magma erupted on surface as the Coppermine flood basalts, and that would be the green unit to the north. There were kind of four main units within the Muskox intrusion itself. You have what's called the feeder dike, and that it extends to the south of the main intrusion, but also underneath it. You have the marginal zone, which is kind of the orange unit along the edge, and that's where the bulk of all the mineralization is within the marginal unit, and that's also the unit that would have fed the overlying flood basalts. Then the center of this big intrusion is filled what's predominantly cumulate ultramafic rocks, and that's what's called the layered series. And then you have a roof zone where the intrusion interacted with the overlying rocks, and you develop this roof breccia. Intrusion is up to about 2 kilometers in thickness, and that was determined by some GSC drilling that was done in the early 60s. So in general, just think of this intrusion as basically a large funnel-shaped intrusion that represents a staging chamber for material coming from the mantle up into an intrusion and then erupting on the surface as flood basalts. So just some kind of visuals of what the area looks like. And again, echoing back to the idea that it is sort of a funnel-shaped intrusion, these are two images taken from the same spot, one looking to the south and one looking to the north. And because the rocks are predominantly ultramafic in composition, they recessively weather. So you actually do develop this basin bowl-shaped intrusion where the higher relief areas are actually the country rocks. And in this case, you can actually see the feeder dike extending to the south. And this bowl shape represents the Muskox intrusion. In this image on the left, it's about 1 kilometer wide. And if you look on the one on the right, it gets up to about 11 kilometers at the around McGregor Lake. And there isn't that much exposure of material in the middle, but you do get the contacts well exposed, and this is where the gaussins develop. So all along these edges will be mesosulfide gaussins and sulfide gaussins developed over tens of kilometers. So looking at a bit of a cross section through this, the pink units represent the older country rocks. The Muskox intrusion is made up of the orange marginal unit, which is connected to the feeder dike below. And then you have the layered series, which is predominantly ultramafic rocks. And then you get this kind of red unit here, which is a bit of the roof rock where you have this interaction with the overlying sediments. And then, as I mentioned, this material at some point broke through that and erupted out on the surface as flood basalts. And that's what the green unit is. So there's a multitude of different mineralizing environments within the Muskox intrusion, which makes it pretty unique. And all these different environments share characteristics with some of the other big world-class deposits like Norilsk, Sudbury, Voisey's Bay, and even the Bushveld. So there's 4 styles of mineralization that have been identified on the Muskox, associated with the Muskox intrusion. We only have 3 on the property that we have, but there are stratiform reefs. So these are chromite-bearing PG reefs like you'd see in the Bushveld. And they extend for tens of kilometers. They're usually higher up in the sequence within the layered series. You get mineralization associated with depressions in the basal contact or within the adjacent footwall. So this is something that we see in Sudbury a lot, and also at Norilsk and in Voisey's Bay, where you'll get massive sulfide along the contact of the intrusion. The keel zone, which is the number 3 here, that's kind of a unique area that I think is very prospective, and that is very similar to to the ovoid deposit in Voisey's Bay. So this is where you have the feeder dike entering into the main intrusion, and that environment where you go from a concentrated dynamic flow of a dike into a big intrusion results in the deposition of the sulfides that are being carried with the magma as it enters into this big intrusion. And as I mentioned before, because we've been along the feeder dike and the feeder dike is mineralized from one end to the other, we know that the mineralization is being transported up into the intrusion. And then the feeder dike itself is a target that has seen very little exploration. It extends for 60 kilometers to the south of the main intrusion, but also 40 kilometers underneath the intrusion as well. So it's a big target. It has lots of similarities to Sudbury, to the offset dikes, and to Voisey's Bay as well. So we'll kind of go through examples of the three that we see on the Muskox project. So this is looking at basically high-grade mineralization at surface associated with the contact. And the picture on the left is the extensive gaussons that are developed along the margin. On the right is just the intrusion with grab samples color-coded based on nickel plus copper grade, with the larger purple diamonds being greater than 5% combined. So these gaussons are extensive. They go for 30 to 40 kilometers. In this picture alone, this gausson is probably 4 to 5 kilometers in length. It occurs within the marginal units, which is either a gabbronorite to a peridotite, or it's within this thick zone of Hornsfeld metasediments adjacent to the contact. Like some of the other deposits like Norilsk, this is actually more copper-rich than nickel, so it's 2-to-1 copper to nickel, and you get very high precious metal values up to 5 ounces, but again, and palladium dominant to platinum. So these big gaussons are what gets everyone's attention, and it's pretty hard not to see that when you're actually up there, because they're so extensive, and this is just not something that you see everywhere in the world. But it's not just its surface. The historical work has also produced some pretty spectacular drill intersections targeting this surface mineralization. So a lot of the previous work that was done was all very shallow drilling, and it was basically drilling down dip of these surface zones. And here are just a variety of holes dating back to the Inco in the early 50s to some of the last work in 2007. And you can see some spectacular grades, good interval thicknesses, very high grades, again, more copper dominant than nickel, and very high precious metal values. And for myself, one thing that I always look for in a characteristic in a nickel project is, does the system have the potential to produce high-grade massive sulfide that you need? And in particular for this project, given its location, you can't have marginal grades. You need high-grade polymetallic mineralization. And that's a theme that will echo throughout this, is that the Muskox has that ability to produce high-grade massive sulfide. We see it on surface, but we also see it in drill holes. So just some of the styles of mineralization. Although there's extensive mineralization at surface, it is really challenging to find fresh material. Most of it is either really gaussonous or it's covered in lichen. But here are a couple examples, and they may be hard to see, but on the left, we've got kind of a breccia-hosted massive sulfide, where you can see massive sulfide wrapping around country rock fragments. The middle photo is these large magmatic sulfide blebs, where you'll actually get the separation of pyrrhotite and chalcopyrite. And interesting, on the right side is massive pyrrhotite and pentlandite crystals up to a foot in length, surrounded by loops of massive chalcopyrite. And this is something that you do see in a lot of the world's big polymetallic copper nickel PG deposits. So we see kind of the whole spectrum right here, and a wide variety of different sorts of mineralization. And again, this mineralization is either in the gabbronorites along the contact, or it's actually in the footwall mineralization. But it is something that, in this case, it does have copper, nickel, and precious metals, but it is more dominated by copper and nickel. The other thing that we see, which is quite unique in something that you don't see in most systems, is we see high-grade copper footwall mineralization. And this style of mineralization is quite common in Sudbury and in Norilsk. And and Muskox is one of the few locations that have actually seen this, other than Sudbury, where you actually find high-grade chalcopyrite footwall veins, massive sulfide veins within the footwall. And this is quite unique. And if you look at, these are some of the drill hole grades, where you'll get, meter, 2 meters, up to 3 meters of 15 to 20% copper mineralization with multiple grams of precious metals. And like I said, this is pretty interesting. This is usually suggesting that you've got a fractionated system where this copper-rich material is coming off of a source. And the big challenge here and the big question is, where is that source? And I use this little schematic in the diagram in the middle, which is of the McCready West deposit that's owned by Magna Mining in Sudbury, where they have a copper nickel rich contact deposit, and then a copper PG rich footwall deposit that's actually separated. And, kind of just put on the hypothetical erosion level for the muskox, this is what we might be looking at, where we have just the tail end of these copper systems, and just down dip could be the source of this. And again, most of the drilling done in this area is kind of about 100 meters depth. So tons of potential, not something that you see very often in these sorts of systems. And this is what really gives us a lot of confidence and hope that there is some significant mineralization on this property. So just touching on that, we feel like we see the complete kind of magmatic system here. We see contact style mineralization, that same sort of things that we see at Sudbury, where you've got more nickel and copper and probably less precious metals. But, of interest is that we also see this footwall component, where you'll see sharp walled massive sulfide veins in the footwall that are very high grade in copper, but also in precious metals into the ounce sort of range. And, this echoes of what we see in Sudbury. So the next environment is the keel zone. And again, this to me is one of the more interesting targets that has really not been tested. And a good analogy for this would be the ovoid. And this is where you see the feeder dike entering into the main intrusion. And that top right would be the example from the ovoid. So they have the feeder dike coming into the main intrusion, and where that happens is where the sulfides drop out. So you have a dynamic system in the feeder dike that's carrying sulfides. When it enters into a big intrusion, you see a reduction in velocity, which causes the sulfides to settle out and form a deposit, in this case, a very large high-grade deposit right at that interaction. And, that's a target on the Muskox property that goes for 40 kilometers. Some of the work that was done in 2007, which is probably some of the last work that was on the property, started doing some controlled source magnetotellurics, looking for that. So this was work that was done post Voisey's Bay discovery and really Voisey's Bay development. They were targeting that feeder system underneath the main intrusion. And this is really interesting, where we see these MT profiles that clearly show the intrusion, but also show the feeder dike in the keel zone beneath the intrusion. And I think that that's the main target on the Muskox intrusion, which has really never been tested with good geophysics or drilling. And, to add to some evidence, where this zone is exposed at surface, we do see well-developed magmatic breccias, which is really encouraging to see. So the last target zone is the feeder dike. And the feeder dike, as I mentioned, extends to the south of the main intrusion for 60 kilometers, but it also extends underneath the main intrusion for about 40 kilometers. The feeder dike ranges from about 200 meters to 60 meters or 600 meters in width. It's got steeply dipping walls. And what's interesting is that within the core of this feeder dike, there's actually a 50-meter wide zone of magmatic breccia with large fragments up to about 1 meter in size. And this is really quite similar to what we see in Sudbury in the offset dikes, and also in Voisey's Bay in the feeder dikes that feed the main intrusions. This target has basically seen little to no work other than surface sampling. Over that 60 kilometers that is exposed, there's 2 100-meter drill holes, and there's been no modern ground geophysics and no recent airborne geophysics. So it's really a wide open target with huge potential. There is mineralization from one end to the other. I've been on the ground. I've collected samples over that 60 kilometers, and there's high-grade mineralization over the entire length of that, intermittent over the entire length of the feeder dike. And there's kind of two main areas that are that have been sampled, and that's primarily just to do with outcrop exposure. So one's called the Muskox area, and the other one is Spider Lake. And both of those, there's great high-grade samples at surface, and no drilling and no geophysics. So I think and SPC controls 100% of this. And what you need to remember about this, as we talked about earlier, is that this feeder dike represents the conduit for magma from the mantle to come up into this main intrusion. So it's a dynamic environment. It's mineralized along its length, so it was carrying sulfides. And really what we need to focus on is where those sulfides are concentrated. So you need to be looking in a vertical direction as well as horizontally. And one example that we've done some extra work on in sampling is the Spider Lake area. So this is about a 3.5 kilometer section of this 60 kilometer section. The dike is anywhere between about 200 to maybe 400 meters wide. Like I mentioned, there's about a 50-meter wide zone in the middle where you get magmatic breccia, consisting of large fragments of dike material, but also surrounding country rock material. And along this length, we get high-grade values. The map on the left is nickel plus copper, and the map on the right is the precious metal values. So, multiple percent up to 7-8% nickel, copper, and PG values that go up to half an ounce. And, this has never been tested with drilling. What I find that's really interesting about this when I apply it to things like the offset dikes in Sudbury is that the mineralization does appear to be controlled by the same controls that we see in Sudbury. So where the dike has bends in it, where it gets wider and narrower, those seems to be the controls for mineralization. And that's the same thing that we see in Sudbury. So that's kind of a summary of the geology plus the kind of four main mineralized environments. And the next video will look at the results from our 2024 field program. Thanks.